So hello, welcome to the sixth lecture of our Python series. In this lecture, we are going to discuss about functions and function alike things like recursion, scope of that particular function, how to define a function, what are the elements of function, what is a docstring, and what is a return statement in a function, and etc. stuff like that. What is parameters and arguments and etc. So, uh, well, by to moving on that, we need to define why do we want a function. Let's say I want a block of code into. There are multiple reasons. One is for simplicity or for sure. The second is to reduce redundancy in our code. Well, in Python, we have focused in our coding mechanism to reduce the redundancy in our code with the examples of being in list comprehension and dictionary comprehension. Those were the primary examples that we discussed in the previous lecture that helped us in reducing the recurrence of our code. So this is also a similar type of way that we are implementing a function to reduce the recurring code into our code base. This is a method that we apply to do that. Another thing is to create our functions of ourselves. And if we want to like call it later down in our code, we have defined it and it is a complex function, but it has nothing to relation with the main part of code. We can divide the code into segments. And then let's say I create a function x above that main function, and then I'm calling x function inside of the main function to just get the result of that x function because exactly we don't want the whole code as it will create complexity in our code base. So we divide that into various parts to make it easy to code and make the code less complex. So, those are the main reasons that we define a function, and to reduce recurrency of a code, we can basically what I mean by that is we can call the same functions again and again and again and again if we want the code to be executed again and again and again and again. But we need to define that whole code base just only once, and it is at where we define the function. So, when we begin with the function, we want to know how to define that. And to define a function, it is pretty easy. We just have to write the def statement like that. Then the function name. Let's say I have function name of even underscore numbers. Then I type parentheses. These parentheses, we will be discussing it a bit later, but for now we will be going forward with this. And this is the basic layout of a function. Let's create up a list over here, and this list underscore number. This list will contain, let's say, elements of even numbers, for example, sorry, of all the numbers, for example. So we can type just I for I in, let's say, range 11, want first 10 numbers. So we'll take 11 as the range, and that's it. We can here only do that if and so on. We can here also do it, but to describe the function a bit better, what we can do is we can then print it down. Let's say if we define it here only. If I modulus 2 equal to 0, we get the range, and then we print this list underscore num. That is it. That is how we define a function in Python. It is the most compact and efficient way to define a function in Python. Well, you can also expand this statement if you feel that it's a bit complex. but that is how you define a function, and when I call it, it will not be running, as I have not called the function yet. So how do I call this function? So at any point after the definition of the function or the function is defined, we type even underscore numbers, then parentheses, and that will make a call towards that function. When Python reads this statement, it has already know in the above definition, it knows that we have defined a function now called even underscore numbers. So it will take us back to that point in our code, and then it will enter the function and it will do all the operations that are inside that function, and then we can proceed. So for example, it will print out all the even numbers in that range, 0 to 11. And let us discuss a bit about what is actually inside the parentheses. Um, Prior to moving to that, we may discuss one more trivial thing about the functions. We have seen the multi-line comments a lot in our journey or in our lecture series. So these triple lines means that it is a docstring inside this function. So what is the primary function of a docstring inside the function? The function of a docstring is to define let's say, another developer, what this actual function is doing. So, like, we are defining a function called even underscore numbers in which, let's say, we created a list called list underscore num, and we print out numbers stored in that list that are even. So that is all. And then as it is a multi-line comment, we can enter it out to make it a bit more compact and readable. So that is the purpose of docstring. And will if you go on to any, let's say, this is a basic level, will but if you want to understand it a bit more, let's say you go on to a GitHub repo and then you go on to their code bases, and then when you see their functions definitions and in which there is a docstring, you'll get even a better idea. So like think of it as a homework. Go ahead, find a GitHub repo and see its docstring functions to get a better hold on how docstrings are formatted, and then correct this docstring over here according to that format. So that is all, and when we execute it, we enter the function. So, well, that is all and all good. But what about, let's say, I want to give the function some matter that it should pass inside of it, and it should do the operations on it only. And it should give me an output of the even numbers. Let's say I have another list of my own, like list underscore num2. Well, so yeah, we were creating a list too. And in this list, let's say we show some other elements such as random numbers, 3, comma 4, comma 5, comma 2, comma 1, comma 4, 3, comma 6, comma 8, comma 12, and so on. These are the random numbers that we store into it. And then what we want this whole list to be passed into this even numbers, and then it should give me a positive or an even number range, a positive even number range. Will we have all the positive numbers in it only? So let us pass into it, pass our argument. So for that, we need to do one thing, and that is understanding what is an argument and a parameter. So, well, to define out a parameter, um, yeah. So, well, to define out a parameter, think of it as a statement that the function uh, in which we define, when we were defining the function that is requiring an input from the user or from the code into the function when we are calling the function. And an argument is exactly the same thing, but think of it as the statement when we are passing down that particular value, it is called an argument, and there can be two types of argument, keyword arguments and no and positional arguments. So keyword arguments, let's define the parameter first. So as we described parameter, it is the function, it is we call parameter an attribute of the function when we are defining that function, and an argument, let's say, uh, is then when we are defining the function call. And there are two type of arguments. First is one is keyword, and the other one is positional. And the second one was positional. So keyword argument is when let's define parameters, and then we will understand keyword argument and position argument. So how do we define a parameter? We know that we define them when we create a function and they require an input, which is called an argument. So how do we define a parameter? These two things, argument and parameter, are interchangeable. We will see how. When we define a function, let's say x, y, z, and then inside parentheses, we define out a parameter. Let's say it is a variable of some sort that will store any kind of value. Let's say we give it x, we give it y, we give it z. There are three parameters to it that are x, y, and z, and the function is, let's say, to print x comma y comma z. The function is to print that whole thing x, y, z. So we are calling a function inside of a function that is possible. And to do that, we first, when we call the function x, y, z, and then the parentheses, then here, if we are not giving it some values, it will cause an error because arguments are not created. So let us do one thing over here. We will create list over here, list underscore x, and we will do one thing, and that is take out the elements from this list x rather than range. And when we will call this function, it will give an error because there has been no arguments passed into it. Therefore, the parameter is not defined. Like the argument is not defined, so therefore parameter is defined, but the function call is not defined. Therefore, not giving any values into the parameter, and when the function is called, there will be an empty list x, and we can do nothing, but it will give an error. And let us print down list x2. It will give out none, as it not exists. It will give an error because it not exists. When we run it, see, there is an error here. Um, and what is the error? The error is that there is no positional arguments passed into it and one is required. So now we can discuss about positional and keyword arguments. The first thing is keyword argument. Well, let's assume that we have multiple parameters, like in our XYZ function, we have, and then we want to define the XYZ when we pass down the function. But like in the positional argumentation way, we define them in the exact order that the parameters, their respective parameters are defined. Let's say 20, 40, 50. 20 is assigned to x here, 40 is assigned to y here, and 50 is assigned to z here. But let's say I want to give 40 to x, 20 to y, and 50 to z only, but want to keep that in the exact same order. So what I'll do is y is equal to 20, x is equals to 40, and z is equals to 10 or 20, I don't remember. So that is the thing over here. We'll define it this way. This is called an keyword argument. We are defining it with respect to the keywords of the parameter, the value, and therefore it will store that exact value, that exact argument or value with respect to its parameter. And let's say I will store it the plain way and not assign a parameter to it, but it will store it in the same order. In this case, then x is 20, y is 40, and z is 10. So let's say when I execute this now, and here there is only one argument, so it will just take the argument as it is, as there is only one parameter. Print. Exactly. Therefore, we get the positive even numbers over here. So let us see one more thing, and that is this second argument into this function. Let us also do one thing, and that is create a list underscore two. And what we will do is we will concatenate them later on after we create them. List underscore num one equal to similar expression, or let's say let us define it with an integer. Let us define it with an integer, and we will take that integers. Yes, let us do that. So we will define it as an integer, and we will take multiples of that integer. So it is x over here, list x and x. And now we have to define x, and x we will be taking as an input over here. We will be dumping some more numbers out here that will define it. It's valid till the first 10 numbers. Multiples are in the first 12 numbers, first 10 numbers. And yeah, that is it. Let us also go to the 49, 81, perfect, 27. It has more values inside of it now. Let us store some 5 multiples too. 10, 20, 15, So now when we call for input of an integer number, that will be the argument, second argument into our function, then the function it can be considered as multiples, the function name. So yeah, we were discussing about it, a multiple and multiples. And then when we ask for, let's say, a number from 1 to 10, mm, hmm, and then when we ask them for an input of it, so as we can see, this function does not exist because we changed the name of the function. We just copy this name and then let us post over here this name. And then when we enter the x value over here, um, it is what it will be doing is it will be starting it as a positional argument. As we discussed, there are two values corresponding to the parameters which in which order they're defined. So it will be taking as it as a positional argument. But we will see when we swap these values what will happen. It will give an error. We will see it later. Let's say I type 7. I have the multiples of 7 from the list. Perfect. Let's define this list X. Hmm. So let us swap these values a bit. And as you can see, we can use these values outside the same as the parameters we are creating over here. This is also one thing in Python that is known as, in any programming language actually, it is known one thing as a scope. We will be discussing it in a bit. And it is related to a function definition only. So let us define x in the initial starting, and then when we execute it, it will be producing out an error, and we can see that as we'll type out 2 over here, and when we execute it, it will be creating a type error. Why a type error? Well, the types are not matching. What is happening exactly is that x is storing, uh, list x is storing x as a valid argument, and list x is storing list x as a valid argument. But later on into the function, when a single value is defined in a for loop, it will be creating an error as it is not a list. And then we are printing down a list over here, and then we are dividing it, modulus function. We are doing it on one number by a list. So therefore, it will have some problems as a modulus function is not designed for a list. So to deal with that, we created something known as a keyword argument, in which we define a keyword first and then later on we define the function. So think of it as a print statement. When we execute, we have seen quite a lot in a print statement, right? So when we execute these things, uh, called as a separator argument, separation argument over here, and then we type another thing, and that is end argument. What are these doing is it is taking it as a keyword argument into a function. So that is how actually we define out a keyword argument. So therefore, the list x, the names are similar, so it is easier to just copy paste. List x is equal to list x, and x is equals to x. So as you can see, we defined it perfectly. The one thing over here is we also see how separation and end are working. So when we execute it, these are also keyword arguments. When we execute it, it will ask us again for, let's say, an input. Two, it will be printing on the list correctly. So that is all with the functions and argument parts. So as now we have understood it quite well, now let us type down an example function out over here. This is an example and it is a problem for the audio for the viewers too. So in this problem, we want to create a function that will give us all the elements that are prime numbers till that particular numbers. The concepts involving this is loops, majorly for loop, and you can also do list and stuff like that. But you have to define it inside of a function, take arguments from the user, and implement this part. So pause the video right now and do this. So to solve this question, we will be defining a function, then after which we will be defining the function name will be prime underscore number, then inside we will be storing x, and inside this function we will be running a for loop. Prior to that, we will be creating a Boolean value of which will it is prime, and that we will be storing as true initially, after which we will be typing a for loop in which we will be iterating in the range uh, that will be starting from 2, which is the first prime number that we can get, till, let's say, x plus 1, and this will be inside of a negative, it will be side of an under root. So that is it. And then we will be entering over here. We can check whether or not it is a multiple of any number that was inside that particular range. So if, let's say, x modulus r, sorry, is underscore prime, not I, then equal to 0, is underscore prime equal to, and let it remain true initially. And we can pass if is underscore prime, which is a Boolean value, and if it is true, then we can type print yes, else print no. So this is the implementation that we have. And when we call the function prime underscore number, and this the value is 2 over here, when we execute it, hopefully it is correct. Okay, it is showing an error. Float objects cannot be interpreted as an integer, so we will be typecast. This is a float expression, I think so. We will typecasting it into an integer by constructor function, and then we will be rerunning it again, and it is presenting itself as 2. Wait a minute, it is not asking us for. Okay, yeah. So yes, it's true. If we define it as true, so let us create an input field, or we can define it inside int input number, perfect, and then will be executed. Let's say the number is 7. It says that it is tested with 9. It's 4. It has to be false. So there's another error in our code. Well, we will see it. So yes, there are some errors in it inside our method implementation. Here we need a square root rather than a -2 powered number, and over here we want to add it after the integer declaration one, as it will be bringing the range down to the next number. Therefore, the under root will be included, and root number will be included. So now when we execute it, I think so it should function perfectly. Let's run it again. 9. Yes, it is working fine. And let's take up the prime number. 13 for the case. Yeah, it is working fine now. This is the correct implementation of a prime number in Python to check whether or not our number is prime. So let's say we have a list of numbers, list underscore numbers, then we over here have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, till 20. We will be having these numbers, and now we want to check whether or not these numbers are prime or not. So what can we do is we can just store this value inside this loop over here, and we can iterate on every value of it, and that is also a homework assignment for the viewers to implement such a way that we can do so. Pause the video and try to solve it. We will be solving it later after it ends. So yes, after it, we are going to implement it. So as we can see, currently in the function, it is just taking one argument. So I think so we can just run up another iteration over here, tab it, enter it. Then what we can do is we can create a list, another list, uh, prime underscore numbers, um, numbers, and in which we are going to store these numbers. And for I in, let's say, this particular list that we're going to take, for x, let's say this must be x, this is a list, numbers, and for x in list underscore numbers, we're going to iterate on it. We will be taking one x at a time, and then we will be adding printing yes, or let's leave it printing yes or no. And let's append these items, prime numbers dot append x, and we can just let it be, pass. This is a keyword that this is a value that we can just use as a placeholder. If we don't have any code inside of it, it will be passing that value. Or triple dots, we have discussed it previously, I think so. So let us run now and see whether or not we are getting the values. So for that, we can do one thing, and that is print numbers, say prime numbers, and we can print on this list. Let us run it and see. Okay, another thing is that with the input over here, we can change it. Left underscore num. Now let's run it again. As we can see, it is perfectly working fine. We all have all the prime numbers in our list. So we have implemented the function correctly. That is it with this part of the lecture. And now let's focus on understanding the concept of scope of it. So scope. Think of when we are defining functions inside of a function and outside a function in Python, we cannot really access the variables inside the function that we define inside the function outside that of a function, particular function. And let's say we create a global function, a function outside that particular function into the main code, and then we try to use that variable inside a function again, give it a value, and then we call the primary value that was stored inside of a code, we cannot really access it. Well, this is because that is not defined as a global term. So it is defined in between local and global scopes. So a global scope we are trying to understand. Global scope is outside that particular function. Like as this we can see in the previous case, let's talk about with the prime numbers case. This whole thing outside the function is a global scope. This is part of the global scope. And this whole interior side of this function is part of the local scope of that function. So if let's say I create, I define, um, let's say a variable a initially, a is equals to 0, and then over here I try to call it a, and then let's see what gets printed out. It gets printed out over here correctly, as it is taking the value from the global scope. But let's say we define a as this, delete to, and we try to append another list to it, s. Then when we run it, we would encounter a function about unbound local error. Well, we are defining that function inside of the local scope of that function. We are defining that variable inside of that local scope of function, and we are appending to it with respect to a global scoped value. So how to deal with it? What we can do is we can define it as a global value. So we define it as global and then enter it and then global A. So we take this element from here and we define it inside the local scope that it is a global element, and we want to do some modifications on it inside a function, and that is concatenation of those strings. Then let's say when we execute it, it is correctly getting executed. So that is the case over here with the global and local aspect. And let's say I type print over here and I try to pass mm, what prime numbers we created by prime underscore numbers. We created this part, and when I try to print this, it will also give an error, that name error it will give, because it really does not remember anything that is defined in the local scope. It does not really define it into the global scope. So that is the issue with that. And let us talk a bit about how do, so that is all about global and local scopes. So now, as we're seeing in this function, we are constantly printing out our values. And we don't want to print out our values, but let's say I want to assign this function um, to a variable, and I want to store that variable's value and later use that variable down in my code, into my code. Prime numbers are used for encryption purposes. So let's say it is an encryption model, and I want to use these set of prime numbers later down into my code to do some sort of encryption with them. Let's say these are a various amount of prime number list. It contains n number of elements till 10 to the power of 6 or 5 or something like that. And let's say I want that much numbers. That is pretty easy. What I have to do over here is I want to just type for I in what I have to do is, okay, it was depend over here. So let's take it. And then after it, I can define the range that will be from 1 to, let's say, 1,000, 10,000, and let's say 100,000. And when I execute it, it gives me all the prime numbers till that point. As I can see, it starts from here 0 because I defined it from 0, and 0 and 1 are not really defined in our case, so it includes them too. But we can exclude them, but the rest are all prime numbers, as we can see. So these are all the prime numbers. And let's say I want this value to be assigned to x, but I cannot really, because when I do that and will, let's say, print x out, it will be printing inside the function, and when I print x out, it will be assigning none to x. I want the values of the function, like this value inside this print statement, get passed inside this function over here, inside this variable over here. The list should be assigned to this variable that I'm creating. So for that purpose, what we what Python does is it has created a return statement. And let's say type 2 to 3 values consecutively, like in this case, it will create them in a tuple. And as I can show it to you, it creates a tuple as the curly brackets as the round brackets indicate the tuple. They will be at the initial point also. Wait a minute, let me just decrease the range. See, there is tuples, and inside of it we have all the values, and this is the element one inside the tuple, this is the element second inside the tuple, and we can do modifications on the list as we want after. So it creates it like that. So that means we can do multiple assignments on it, like multi-value assignments, like A and S, X. So it will do this. It will store X to this, and A is getting reassigned. So as we can see, return function, return statement. works in that way. So now as we have discussed majority part, now let's create a recursion for now let's discuss recursion function. So recursion is pretty simple. It is the process of calling the exact same function inside of our function until the point we get the desired result. So kind of like defining a factorial function for the case. X is the value of factorial. Um, so what are the basic rules of defining a factorial? Is that if it is 1 or 0, or x is equals to 0, then we will execute it and store and return 1 as the answer is 1 to them. Else, what we can do is we can just call this factorial function once again inside our code base 2x minus 1 and x is multiplied with it until it hits 1 or 0, 1, until it hits 1, then we are returning 1 over here, and then it will compute all the values till that point. Yeah, I guess there are some errors in map implementation. We will be seeing that. So let's define x is an int. So let's define x over here, x factorial. It is x is inside the local scope and it's a parameter. So the global scope x is not related to it in any kind. So let us just call it like that. Input number and then let's execute it. Mm, So we will defining an factorial of 2. The answer is, wait a minute, we are not printing the answer. Print x, and the answer is 2. And then we execute for 4. The answer is the factorial of 4. When we execute it for 3, the answer is 6 exactly, and 6 would be. Then when we do it for 5, it is 20.5, and it is the correct implementation of factorial function. So therefore, we define recursion over here. So what recursion actually does is it calls the function inside of that function, same function, until and unless we get our result. And in factorials, we can define it the better way. We can also define factorial with the help of loops, but that is for the viewers. Do that assignment on your own. So let us move forward. And after factorial, we will be defining some statements that will be helping us further on into the codes, uh, like break, comma, continue, and pass. If you don't know these statements yet, we will be defining those. They are mainly used in loops and conditional statements, such as if this is true, then implement this as part of the code. Else, if we don't want another thing, just continue. Simple as that. So we can also implement that in loops, for example, and we can also pair loops with the else statements. So let us see how we can do that. Let's just define a number list from ranging from, let's say, 20, range till 20. Length is 20 of this list. Then what we can do is we can create a for loop for I in num, and then we can execute it if, let's say, I is getting divided by 2. What we want to do is number want to continue, and let's say we want to store all the odd numbers, and we can create another list called as odd underscore num. This list contains nothing, so what we can do is odd underscore num dot append I. So when we execute it, we will be getting all the odd numbers. Wait a minute, we are not printing it or what? Yes, we are not printing it. So let us do one thing, and that is print underscore odd underscore num. And here we go. We got all the odd numbers. That is one thing. And the use of continue statement. We can also use pass over here. And but there's a difference, right? As we can see. Why we use continue and pass. Pass does an action that we need inside of an else statement rather than an if statement. What it does, we will see though the difference with the help of our debugger too. We will be pointing a debugger right across over here, and let's run it. Run on debug, Python debugger, run file. So we define the number list, and now we are getting into the for loop with the number list, and we are iterating over it. So when we use continue, it breaks the loop at that point and it starts the next iteration altogether, as we can see. But let's say I type pass over here. So we will see now what will happen. What it will do is it will let it stop and rerun it. Rerun the debugger. So now what will happen is it will let it pass through the next lines of code also. And as we can see, it is taking all the code and appending it to the odd number list that we don't want. So that is the basic logic. And I think so you got it. It's pretty easy. Now let's move next on to the break statement. So let's say whenever I encounter a number or any case, let's say for my, let's say if I encounter 10 and it is I, then break the loop at that point, and it will just only give me the values that and we can just type an else statement over here. Else statement will execute with the reference to the for loop. When the for loop ends, else statement just goes. We can do print all the values are printing, and let's just run the file. Wait a minute. Let's rerun it again. Well, it's not printing. Well, let's run the debugger once again. 7, then the iteration 9th and the 10th, it will be breaking and it will be moving on errors. But let's say I want um, to execute it. Let me just put it as continue and then let my loop be completed. I guess then it will be running. Yes, yes, we were breaking out of the for and else block. We can also use break in the functions to break out of that function. And that is all for this lecture part of pass, continue, and break. So now let us talk about unary operators. These kind of operators only, and this is the last part of the lecture, these type of operators only work on a single operand. For an example, logical not, bitwise not, the positive operand operation and the negative operation, positive sign operation and the negative sign operation. So think of it as like a is equals to 2 and we are redefining a, so we will be defining it a plus a. So then we will be printing it. It is not incrementing here. For incrementation, it should be previous to the equal to sign, but it is not incrementing. It is just a unary operator. Let us define negative first so we can see the changes. Negative sign, it will be changing the sign of that particular value stored inside of it. Then we will be changing the sign again by this positive sign. Then we will be defining it with not a, that will be 0, and then a bitwise not. That is not this, this is curly 1. Let's just print all the values. And let us execute it now. So yeah, let us do some changes. It is not correctly implemented. A is equals to over here. Then this portion is supposed to be above over here. And now let's see what it is all about. So let us discuss first each unary operator. This unary operator will change its sign to negative of the value stored inside of it. This unary operator will show the sign uh, of the value that is stored inside of it. Negative one will automatically be shown, but the positive one has to be shown by implementing a plus in front of it if it is a plus. If it is a negative, it will always shown as negative only, even if we put a positive sign above it, previous to it. It will just show that it has. It will just show that it has to show the sign of it. Then the not one will just be storing whether or not this is a bool. It will store it in the way of boolean, like any number except for 0 is true. So it will give out a false, and then it will implement it in a boolean way, like 2 is 1 0, so it will be printing out as 0 1. Basically 1 it will be printing. This, as we can see, it is implementing it correctly. So yeah, one more thing, the not is not printing as 1 because it's also storing the numbers in front of it, like like 16-bit, 32-bit according to your system, 64-bit type way. So therefore, it is storing the value in the way of 2's complement, which is a discrete concept. Therefore, this value is -3 or -3. So that is all for the lecture. Thank you.